Welcome to this Intro to Smart Grid training. This module will provide you a basic understanding of the electric smart grid technology. It is a continuation in the Utilities 101 Overview training series. Before we begin, let's discuss how to navigate this session. To the left of your screen is a table of contents. Once you have completed a page, the table of contents will allow you to navigate forward and back to the viewed page. However, you are unable to navigate ahead in the training to view pages that you have not yet completed. The session must be done in order. At the bottom of your screen is the navigation panel. This panel will allow you to perform basic functions such as pausing the session, resuming play, and adjusting the volume. If you place your cursor over the navigation panel at any time during the training, you will see the function of each button appear. Training includes audio. If you're in a shared environment, please use headphones. To proceed, click the play icon or click anywhere on the screen. Let's take a moment to make sure we understand the objectives of this session. By the time you complete this training, you should be able to demonstrate an understanding of the following. Define the purpose of a smart grid. Describe the smart grid components. Identify utility and consumer smart grid applications. As part of demonstrating your understanding, there will be required knowledge checks during this session. One knowledge check will be at the midpoint of this training. The other knowledge check will be at the end. Both knowledge checks will be graded. You must earn an overall score of at least 70% to pass. If you do not pass, you may retake the knowledge checks again until at least a 70% is earned. Successful completion of this training is also contingent upon each page of this lesson being completed. So please do not try to skip pages or end the session early. Otherwise, you may not receive credit for completing the module. Please allow for approximately 30 minutes to complete this training. You may be asking yourself, what is the smart grid? In this section, we will cover the following topics that will better help you understand this concept and even how Itron fits into the puzzle. The smart grid, the smart home, renewable energy, consumer engagement, operation centers, distribution intelligence, and plug-in electric vehicles. Our current electric grid was conceived over 100 years ago when electricity needs were simple. Power generation was localized and built around communities. Most homes had only small energy demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes. A meter reader would come out to your home in person and write you a paper bill once a month. This limited one-way interaction made it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and environmentally greener. The smart grid enables newer technologies to be integrated, such as solar and wind energy production and plug-in electric vehicle charging. With participation from informed consumers, the smart grid will replace the aging infrastructure of today's grid, and utilities can better communicate with its customers to better manage electricity needs. The smart home communicates with the grid and enables consumers to manage their electricity usage. By measuring the home's electricity consumption more frequently through a smart meter, utilities can provide their customers with much better information to manage their electricity bills. Inside the smart home, a home area network, HAN or HAN, connects smart appliances, thermostats, and other electric devices to an energy management system. Smart appliances and devices will adjust their run schedule to reduce electricity demand on the grid at critical times and lower consumers' energy bills. These smart devices can be controlled and scheduled over the web. Renewable resources such as wind and solar are a sustainable and growing source of electric power. However, renewable power sources are variable by nature and add complexity to normal grid operations. The smart grid provides the data and automation needed to enable solar panels and wind farms to put energy onto the grid and optimize its use. To keep up with constantly changing energy demands, utilities must turn power plants on and off depending on the amount of power needed at certain times of the day. The cost to deliver power depends on the time of day it is used. Electricity is more costly to deliver at peak times because additional, often less efficient power plants must be run to meet this higher demand. The smart grid will enable utilities to manage and moderate electricity usage with the cooperation of their customers, especially during peak demand times. As a result, utilities will be able to reduce their operating costs. By deferring electricity usage away from peak hours, and having appliances and devices run at other times, electricity production is more evenly distributed throughout the day. The power being used right now was generated less than a second ago many miles away. At each instance, the amount of electricity generated must equal the consumption across the entire grid. Electricity is very difficult and expensive to store, so it is important that the amount generated closely aligns with what is being consumed. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption in real time. This greater insight and control reduces outages and lowers the need for peak power. In control rooms across the grid, engineers will be able to more precisely and predictably manage electricity producing, reducing the need to fire up costly secondary power plants. If you have taken the Utilities 101 module for electricity, you are already aware that the distribution system routes power from the utility to residential and commercial customers through power lines, switches, and transformers. Utilities typically rely on complex power distribution schemes and manual switching to keep power flowing to their customers. Any break in the system caused by storms, bad weather, or sudden changes in electricity demand can lead to outages. The smart grid distribution intelligence counters the energy's fluctuation in outages by automatically identifying problems, then rerouting and restoring power delivery. Utilities can further use DI to predict and manage electricity usage with the cooperation of their customers, leading to lower production costs. The charging of a plug-in electric vehicle can be managed over a home area network or HAN. The HAN can balance the demand for electricity across the household and prioritize between the electric vehicle and other appliances to manage electricity usage and reduce costs. With smart grid technologies and consumer participation, utilities can more easily handle the increased demand for power to run the electric vehicles and ensure charging needs are met. By adding more electric vehicles to the grid, we have the potential to reduce fuel costs, lower our dependency on foreign oil, and help reduce greenhouse gas emissions. We are about halfway through this session. Let's take a moment to check your understanding of what we have covered so far. As mentioned at the beginning, there are 2 knowledge checks. This is the first one. You must earn an overall score of 70% combined to successfully pass this course. Your score will be displayed at the end of the training session. When you are done with the first knowledge check, continue on to learn more about the smart grid by deep diving into the basic components of the system. Now that you have a basic understanding of how the smart grid works, let's review some basic components and learn more about how Itron utilizes various solutions for our clients. Not every component of the smart grid system may be utilized for every client or consumer. If you put the entire system together, it would look something like this. This graphic is a high-level overview of how each component is related to each other. Click on each solution to read more about each component. After completing this training, there are additional OpenWay training resources and videos available to you that will allow you to deep dive into the OpenWay functional basics. Now that we are ending this Introduction to Smart Grid session, it is time to take the second and final knowledge check. Once you are done, your overall score will appear. As stated before, a 70% or higher is required to pass this course. Please make sure you continue watching the entire session through the Congratulations page to ensure you receive credit for completing this course.